and we have a lot of people on, so I have to keep moving. Okay, so we'll have time at the very end, but for the sake of everyone's time, I want to make sure we get through the material and then we get to people's questions. So, okay, I have a lot of survey results actually so far that I want to share with you guys, and this is very interesting stuff. I think it's interesting for the whole market. So again, Pipeline is very much production, like application side machine learning. So every other company that you've ever talked to, or any other company that you've ever read about, or product that you've read about, or open source project, is always, always, always on the training side. Training side, we have been doing our entire careers, and we're not interested in competing in that space. There is a huge under-engineered phase between training and the applications that is very, very much under-engineered, and that's what we've spent the last couple of years developing and prototyping, and finally now bringing to market. So we have open source. I posted that here. We also have quick starts. If you go to quickstart.pipeline.ai, this is a really good resource. Okay, can people hear me? These are the things I do want to stop for. Okay, people can hear me. All right, gotcha. I was recording a video this weekend, and I want to make sure I had the audio stuff set up properly. Okay, so we have instructions on Docker. We have instructions to get Pipeline running on Kubernetes, even SageMaker. We actually are very similar to SageMaker. We have a whole lot of features that we actually can extend onto SageMaker as well. So we're SageMaker friendly, we're Azure ML friendly, we're Databricks friendly. In fact, I'm gonna talk about some of the integrations that we have here in a bit. We just integrated the Databricks MLflow open source project, and we support their experiment tracking and hyperparameter optimization. So all of the offline stuff is stuff that we are picking up from the best in class projects. And coming from Databricks, I know exactly the people that are working on that project, and I'm very, very confident that that's the right project to go with. Okay. One sec here, check invite, boom. It's different than normal. Okay, boom, boom, boom. All right. We also have Kubernetes. So if you didn't want to use SageMaker, didn't want to use Pipeline, didn't want to use Azure, you could actually run your own Kubernetes cluster, or even use Docker Swarm. So it's up to you. You could choose Docker, you could choose Kubernetes. Okay, people are wanting to. So if you go to okay, this is the last question, then I have to continue on. I'm sorry. PipelineAI /pipeline. Okay, I'm going to circle back and get to the unanswered questions here in a bit. I'm just going to put these on down in the corner here so I'm not distracted. If you guys want to join our Slack, join Slack support. We offer 24/7 support. We never sleep. This is one of my personal goals for 2019 is to sleep. Community events, we have this is the monthly webinar. We also have this Meetup as well too. You should check out the Meetup. We post everything there. The next one coming up is October 30th, Halloween Eve. And we have some speakers from Redis coming, which is really cool, talking about Redis plus TensorFlow. So I'm really excited about that one. We've been working with them pretty closely on how to get the best performance out of a C-based project called Redis, integrating Redis streams and integrating TensorFlow, which is also C-based. Initially, that appeared to be a Python type integration, and I pushed back and said, no, you guys have the benefit of being a C-based project, being Redis, and TensorFlow C++. So pointed them to the right resources there and got them in touch with the right people, and they've been cranking. So October 30th, look for a video. If you can't make it in person here in San Francisco, there'll be something posted very shortly. I will also be giving an update on some new advancements that we're creating at Pipeline along streaming and possibly along the Redis streams as well. We'll see how much we can get done between now and then. Also, on that October 30th, we'll be presenting TensorFlow JS. So the meetup is actually being hosted at Cloudflare, and Cloudflare is, started off kind of DNS, type like a GoDaddy type thing, but much, much more sophisticated and much more value add on the web requests. And they could do caching, and they're a CDN. Think of Cloudflare as like Akamai, but very application focused. In fact, we compare ourselves to as the Cloudflare of machine learning. Because we can take these machine learning like predictions and make them faster. We can, batch up requests and like combine things and all the insight that's available. And we could do all the geo routing that you need, any kind of multi-model like combinations. So let's see what else here. I think this is just the thing to highlight here about this open source. So here's the CLI, and this you'll see later when you go into the quick start. You can go right into quick start here. If you want to actually get a model going and push to production and start hitting it with a REST endpoint or a Kafka stream, consuming it from a stream, you can actually do this hosted community, or use our hosted community edition for this. And then, from there, we'll like work with you to get on professional enterprise. Okay, that's the product pitch there. You could also do all this yourself with Docker. You could do all this yourself with Kubernetes, and you could even try SageMaker. So here's the CLI that powers all that. So when I click on here and I see install the CLI, and here, first step, it's the first step. It's so obvious that there's a lot of people that miss it. You'll see it right here. So version 217, and we should be able to go into pipeline, go into the CLI and see all the code that's there. Okay, any documentation is going to be here. Here's all of our Python libs. So this is all stuff that goes into PyPy. This you can use by your model servers to get really, really detailed insight into where time is being spent with your predictions. That's kind of nice. Here's our predict Docker image. So, this is all the code, all the source code. We support JVM models, Java models. We support MXNet. We have Python. Let's see, model server. Yeah, that's actually Tornado based. You can provide your own implementations. You can either commit them or submit pull requests. We'll review them, ask some questions, then pull it in. Also, these dashboards. So all of this stuff is built into one Docker image, which is really nice. So that's on the prediction side. Now there's training side. Training side stuff. So this is pretty cool. You can actually train your model using Docker. And this is very much compatible with the way that MLflow does things. And so we're, fortunately, those two designs ended up being very similar. Having worked at Databricks, I know how those guys think as well too, and we think in similar ways. So the projects essentially came together kind of on their own. Also SageMaker, very similar. So we're excited to offer that. This is just an Ubuntu base image that we put some utility things in there. It's based on 1604. We'll be upgrading to 18 as soon as TensorFlow and some of these other, mainstream packages start to support 1804. Let me show you some of the dashboards here. I think there's an image of it. Yeah, so this was us actually doing an experiment where we were comparing the same exact models running on Amazon as well as Google Cloud. So let's see. Also note that we are tracking cost per prediction. And so this is a case where we were comparing Amazon to Google, the exact same Docker image, very, very similar instance type, similar cost. And Google Cloud actually was coming in a lot faster. And this could be for multiple reasons, which is why we have so much insight into these predictions, is to see where is time being spent. And even down to if it's an AMD chip or the like Intel chip. We actually quite often at at like Netflix, when I was with Netflix, we would find very, very significant like variations or like variances between 2 or 3 different cloud providers, or even the same cloud provider with 2 or 3 different types of EC2 instances. So back in the old days, you really didn't have much control over what type of hardware you would get with EC2. You would just provision a certain number of gigs of RAM and a certain number of cores, and you would maybe one 1/100th or 1/50th of the time you would end up getting an AMD chip. And for whatever reason, that particular workload ended up being 10x slower on the AMD. Now, this isn't always the case. It's not a war between Intel or like AMD. It was more that we had done all of our performance tuning on an Intel, and then when we got the AMD, we would find that it was 30% slower or something like that. So the short of it here is, unless you actually put your code into production, you will never really know the performance characteristics or the cost. And so this is very important. So let me try to shut down my notifications here. Too many people bugging me this early in the morning. Okay, so what we found here was this particular prediction ended up being much more efficient and cost efficient, and even performance. If we ran on Google Cloud. So we ended up, for this particular workload, switching over to Google Cloud. Now, Pipeline has changed quite a bit since these early days, and we can actually dynamically shift traffic based on that cost per prediction. And so, yeah, that's one of our cool features. If we have multiple clouds, and you've set up Pipeline on those like different clouds, we can actually, in real time, adaptively shift traffic to the cheapest cost per prediction. So this is, very, very high number of predictions, very, if there's millions of these predictions per second, billions per second, and we're saving, 0.00002 per second or per prediction, this is very significant. So that's one of our value props there. If I keep going, yeah, we got some Slack integration. That's pretty cool. Okay, so this is like a trip down memory lane. These are small dashboards. Something we also talk about is our native code generation. So the ability to take a decision tree within Spark ML, for example, and we can either export it, either JPMML, for example, or MLeap is another implementation to serve Spark ML models. Or we can even go one step further and natively generate either Java code or C code. These are very, very straightforward things to do with a certain subset of models. And like these decision trees are like perfect for this, because we can look at the graph that's generated from Spark ML or even from TensorFlow. Now, with TensorFlow, we don't find that much of an improvement in performance when we natively generate. The reason there is TensorFlow is already generating C++ out of your graphs. So really, the ability for us to add value here is really from Spark ML, from Scikit even, yeah. So other things. Also too, like we can generate like native GPU code as well too. We've got a couple CUDA experts on staff, and these folks know the ins and outs of the NVIDIA, the NVPTX, which is the NVIDIA Intel instruction set, basically. That's the equivalent. Also, we've got some advisors from Intel as well too that really help us out, optimizing for MKL, which is their version of like OpenBLAS, they're optimized like linear algebra libraries. So here's another thing, we could take graphs and prune them down. And really, we're all about getting graphs and these models ready for production. And I will say that sometimes we don't know if the Java implementation will be faster than the C++, will be faster than the CUDA version. We don't know, but this is where Pipeline comes in, is we'll take one model that you've like created, and we will generate 3 or 4 or 5 or 10 different hardware optimized versions. And this is huge, right? Because again, we're on the billions of predictions per second here, and not the hundreds of training jobs that people typically talk about. So these little minute pennies on the dollar, as my buddy says, these pennies add up when there's 1 billion of them. So I'm just going to put it out there. We support every single language, and yeah, every single runtime. There's no limit. Some people have asked us about Clipper, for example. Clipper is a project out of Berkeley. It's kind of a researchy project. Some people try to use it. They usually end up coming to us. Clipper, we can support the Clipper runtime. We can support basically anything that you give us. We are all framework developers and platform developers by trade. Those are the people I bring in and make sure that we all consistently think about how to open up hooks to the platform. All right, so some of you might be wondering, well, what is this thing? So let me do one thing here. I'm going to put you on pause for 1 sec. I want to make sure the server is up. And okay, yeah, I think it is. All right, let me do something here then. Pardon the hold. Got a little bit of a late start today, so I'm scrambling to get caught up here. Manage pool. Oh, okay, that's odd. Okay, so it looks like I'm gonna have to, oh, no, there it is. Okay, 1 second, I'm just getting this other server up and running here, AWS. Okay. 0, boom. Okay, yeah, okay, so let me get through a couple more of these slides and share with you guys some of the survey stuff, and then we'll do the hands-on part of it here. So we are very much the machine learning application runtime. We feel we're the standard here. We have enough people coming to us, getting enough feedback, enough users where we feel like we have the best open source and the best product on the market. Halliburton actually recently, so they announced in September 2018 that they've chosen PipelineAI for its next-gen AI application platform. So this is us, working with these enterprises and, sort of slowly making these announcements. We've got quite a few also in this similar situation. People come to us they basically want to build SageMaker, but for their own Amazon cluster or their own vertical industry. Yes, I should say it that way. Also, they want a SageMaker that works across all clouds in a consistent manner. So maybe they themselves have a platform, right? Like Halliburton has a platform that they offer to other customers, they're to the Chevrons and the Shells and things. And all of their customers are across all the different clouds. And so there's very, very few companies that are truly multi-cloud, and we've sort of out of laziness been multi-cloud because we were, it's partially my Netflix experience and seeing how locked in like Netflix was to Amazon, which was not a good thing, later on, and they've since made some changes, but still pretty much locked in to Amazon. But it was partial laziness. It was partial, the Kubernetes support for these clouds was always a bit wonky. So the short of it is that we work on all clouds the exact same way. The implementation detail is that we're using Kubernetes and Docker as long as we can get to any Linux machine at all. Actually, yeah, that's not even true. If we can get to a Windows machine that can consistently run Docker, then we're in good shape. And we know Kubernetes runs on Windows fairly well as well too. So as long as we can get to Docker, we can usually get the Kubernetes cluster up and running in a consistent way with all the same types of configuration screens and command line options. Some people have called us WebLogic for the ML application middleware space, and this we like. This actually sits well with me because I used to work at BEA, and then we got bought by Oracle. And then App Dynamics for AI application performance. So this kind of anchors us in both a middleware space and the sort of APM space, right? So here we are on this intersection. We are able to see all the requests flying through the system, all the predictions flying through. And you do your training somewhere else. You can technically do it with us. We are perfectly fine with you doing it somewhere else and just giving us the trained model. There's so many things that you can do these days with these trained models that don't involve the batch kind of stuff. That is more it's more preparation for serving predictions. And this is the huge under-engineered space I was speaking of earlier. So I'll talk about some of these here in a bit. They surface through our survey. Okay, notable quote. So this is actually by Jensen from the CEO of the NVIDIA Corporation. You know, this guy's always kind of fun to listen to. He's a fun guy, you know, kind of wacky guy. Model inference is hard because everything matters. So now this is significant. This is saying that it's not just accuracy that matters, like in the world of model training, but now we have latency. We also have accuracy. Of course, we have to balance between latency and accuracy. And by latency, I mean request, like prediction request latency. This is very important. On the training side, this is not important. It's more important to be accurate. The size of the model, of the actual, you know, because we don't necessarily have unlimited S3 or unlimited, you know, Azure cloud storage space. Throughput's very important. Energy efficiency is very important. And finally, and this is the one that sticks out with us the most, the rate of experimentation is hugely important. So this isn't necessarily a hardware-specific thing or even a software-specific thing necessarily, like the other ones can be directly attributed to the efficiency of the hardware, the throughput of the software. This is how fast can I try something new? And this is hugely important. So this goes back to the core tenet of, I don't know how my workload is going to behave or how this model is going to work with these inputs until I actually get it into production. This is something Netflix did heavily. Very, very rarely did we do or spend a whole lot of time on back of the envelope because we had the answer key, right? We had our, if you will, test environment, which was production. And some of you might balk at that. Well, you can't mix test and production. And I argue that you can. And I argue that with Pipeline, you will. So these are best practices we're surfacing out of, you know, from our backgrounds. We're able to push models into production super quickly, get these things out, and compare them side by side. So we could have the champion model running and 5 challengers that have all been optimized in different ways and see how they're doing. Quick note on traction. A lot of you came through these channels, community edition, talks. Let's see, you know, this slide is right out of our pitch deck, so it's a bit cheesy, but we just hit 3,000 stars last week. Pretty excited about that. Our goal is 12,000 actually by Q2 of next year. So we're ramping up there. We've got some things in the works, some fun little demos and things that will hopefully help that number go up. So the main problem, this is what the VCs love to see, the real world is continuous. This is the problem. Current solutions are offline and they're disconnected. So this is every other solution that you have ever heard of. These folks are all focused on research. They're not focused on production. It takes 1 to 3 months to test a new model in live production. And this is not the high rate of experimentation that Jensen's talking about and that we've used in the past. Less than 1 in 5 models actually goes into production. This is very depressing. This is why are we even modeling? You know, we're losing 4/5 of our time for things that are not able to go to production because they're not fast enough, because they're optimized for a different reason. Because focus has been on training. I don't know, something like this. I'll fix this later. So, and there's this unicorn handoff phase, you know, slow, manual, error prone. Yeah, anytime there's a handoff, we're losing insight. It's a one-way process. There's no feedback. It's just kind of bespoke stuff. So solution obviously is what we're talking about here. 1 click from research to production. Unified multi-model, this is ensembles. Prediction runtime. We can also support multiple frameworks is what we're trying to say in that one little blurb there. And it's a unified runtime across MXNet. You know, anything PMML, anything like Onyx, PyTorch, whatever you got. Real-time model training and validation. This is actually comes in as the #1 most asked for feature, which is real-time model training. And this is something we do and focus on heavily. There's a lot of folks that talk about it, but they're not actually implementing it. We actually implement it and make it part of the platform. Explaining auditing predictions is also very high. This is the ability to plug in different algorithms. You know, you could use Line, you could use your own custom things, something that you buy off the shelf, and you can plug in to us through the platform. Detect bias, detect model decay. These are very important. These were like #3, I think, out of the top 5. 360 feedback. So this is more of a concept here, but it's also, it shows up in dashboards. So the fact that I can see how my training, how that same model did offline, that it did online, and also show me the 5 different versions that Pipeline generated and the optimizations that were made, and show me in production in a safe shadow mode, how are these things performing? So that's the key here, is that there's the shadow mode that by default we run in. This is where the same inputs are going to the current champion that are going to the 5 shadowed challengers. We're now able to look at one dashboard that shows all 5 or 6 models and see how they're doing relative to each other. So not just system metrics, but prediction metrics, like what was actually predicted and how similar are these predictions. Because there's times we've actually caught CUDA bugs that surface through TensorFlow predictions that when pushed out in shadow mode, we saw that it was specifically GPU with XLA, the accelerated linear algebra libraries turned on for TensorFlow. With that combination, we saw very, very poor prediction results. They were fast, but they were wrong. And that actually ended up becoming or being identified as a CUDA bug that has now finally been fixed, I believe, in CUDA 10. So, you can look side by side before pushing that model into production. There were a lot of folks not using Pipeline that pushed that bug into production. Things seemed okay under low scale or under a certain subset of data, but once it got into the general public, they had problems and they were losing business dollars by the minute or by the second. Also, we let you balance and increase accuracy and performance. So you can find the right balance for you or make certain optimization choices and even switch between. You could have part of the day you could be running performance optimized, throughput optimized. Part of the day you could be running accuracy optimized or A/B test in between. And then also, of course, hardware specific optimizations is kind of, okay. So unified prediction runtime, these were the top 5 models that we, and runtime. So Python we know is Flask. TensorFlow is TensorFlow serving, as best as we can tell. Keras is, let's see, Spark, ML, and then Scikit-Learn. Actually, this particular question was, tell us which frameworks are you using? So this is people building stuff in Python, directly and just, for the most part, spinning up a Flask app. This is TensorFlow, probably running with Python is my guess. This is Keras, probably running with Python. Spark ML, which is likely people doing batch predictions. And Scikit-Learn is the one that we know pretty much everybody uses. So there was nothing here that was unexpected. I don't think the Spark ML thing is for the real-time predictions, but they're probably either talking about Spark streaming or they've probably either built their own way to expose those as a REST service. So here's an idea. So Pipeline is a platform. We support these sort of incremental add-ons. The top 5 things people really want to see, and this feeds right into our, this is a private repo that we have. We have over 500 now since this screenshot was taken. We have about 520, I think, of these user requested add-ons. So these are not bugs per se. Some of them are bugs, but this is more around features. So this is what users have been telling us. So this is the benefit of the community that we have and the reason that we do these monthly things. We want to share with you guys knowledge. We want to give you guys good samples. And then in return, we want to make sure that that we are hearing from you guys, and then we can prioritize things. So we have quite a few projects in the works in parallel. Combined multi-model predictions, that's ensembling. Online model training comes very, very high. Track real-time prediction metrics. This is our ability to go into an individual prediction at runtime and see how, at runtime in real time and see how much time is being spent in certain parts of these predictions. This is very important. If you can't get to the individual request, which like a lot of people just talk about batch analysis of this stuff, you are not, you are going to get blown away by your competitor who can get to this data. This is very important that you're keeping an eye on things in real time, setting up alerts if things start to decay, both from a prediction standpoint and the classic bit rot, as they call it, where you just need to push out a new server because this one's has some kind of memory leak or something. So system performance as well as prediction performance, very, very important to keep an eye on long term. Okay, and so like this was a very interesting question that we posted in our survey, and I'm looking forward to the responses that like you guys provide today. Which metrics are most aligned with the value you would receive from Pipeline? So for some of you that didn't know Pipeline, it was probably not the easiest to answer, but you could look at these and see which ones are important to you anyway. Time to deploy new models to live production. This was huge. This is getting it from 1 to 3 months down to milliseconds, and being able to do hundreds per week, versus 1 every 3 months. Large number of models and experiments in production. So this is the ability to manage many different variants and really being able to generate. So if you drop down to number 4, increase performance through auto optimization. So this is our capability, the pipeline ability to generate new model variants is super important. And that actually feeds into this large number of models and experiments in production. We can actually increase the number of models that you're comparing by 5x because of our auto generation. Reduce time to detect bias and model decay, very important. And then this last one, minimize cost per prediction. So very clearly here you see performance, you see like detecting like decay, you see trying to get more models into production and more variants and more experimentation, higher rate of experimentation. Minimize cost per prediction with the adaptive traffic routing. That's what I was talking about earlier, where we trigger off of cost per prediction and either route to a different model variant that's cheaper or route to a different cloud. So this is really the first time that you see people comparing clouds and not just models or just runtimes. So this is kind of interesting. This is top 5 places people want to deploy. So customers' public cloud count, very interesting. Not unexpected, having spent time at Databricks. This is the exact reason Databricks supports running Databricks on the customer's public cloud. Now they do it in a wonky way that is a 19-page setup for Amazon and a equally 15-page setup for Azure. But you log into a Databricks SaaS to their hosted product, but when you launch, you actually launch the Spark servers in that user's, that customer's public cloud account, so their Amazon account, Azure account, whatever. So it's kind of a hybrid SaaS and on-prem situation that's actually very, very difficult to get started, but once you get it going, it works pretty well. On-premise data center, so this is folks saying we actually still have our own data centers and just want to run on OpenStack, something like that. Hybrid cloud, public and private, comes in number 3. So this is the ability to kind of minimize costs and keep things in your like on-premise data center, but then also scale out to a public cloud, when needed. So it kind of gives you the elasticity of the public cloud, but also the privacy and security of your own private on-prem. Pipeline hosted SaaS. So this was our way of kind of gauging, is the market ready to just deploy models to PipelineAI? Are they? Now we also do model encryption. We can run these models with full encryption. So in memory, of course on disk and all the usual, but it's very important that you can load these models into memory and like actually execute them with full encryption, because otherwise, especially with Spectre and Meltdown, you can start to access memory in different VMs, and this is very, very bad. Finally, multi-cloud. So this is across public clouds, and this actually was higher than I thought it was going to be, because I know people talk about this, but and this could be a little bit of bias as to who our audience is. Now this survey is for more than just users of Pipeline. This was for our entire network, and so we feel that, you know, this is a pretty accurate representation of what people are doing and not just what they want to use Pipeline for, because otherwise we'd see Pipeline up to the top there. Here's our typical persona, buyer persona, user persona. So, you know, a lot of VPs of innovation, a lot of VP of data science. Let's see, CIOs, CTOs, CEOs. Also the user persona. So of course, data scientists would be a producer of these models. The cool thing is that these data scientists can actually get the models into production. And a lot of companies focus on that part and the ML ops and the science ops. We feel that we shouldn't even be talking about ops. Let's just talk about the actual use cases here and what the capabilities are of our platform, which is that like data scientists can get models into production in seconds and safely. And let's not anchor ourselves to, you know, Jenkins or to traditional kind of, you know, ops type like workflows or, you know, automations and things. This is really, really for what are the capabilities for this data scientist? What can they do with this platform? The data and then the ML engineer, these are folks that really their role here kind of starts to go to zero. And they can now focus on other parts, right? Like we all have about 5,000 things that we're working on at the same time. We shouldn't waste these people's time with rewriting someone else's code or keeping an eye on dashboards, you know, which like the ops folks already have that stuff down. So let's repurpose these folks, these like ML engineers, and, you know, give them really, really high value stuff to work on, business level stuff to work on. So also, haven't talked too much about the Kafka streaming support, but that's another area where these data engineers and ML engineers spend quite a bit of time, is, you know, pulling data off of Kafka and dealing with Kafka consumers and dealing with Avro schemas, and we're really trying to you know, like give them other fun stuff to work on besides that. The other thing to note is the application developer themselves actually has quite a big part of this platform. So they're consumers of this platform, and I'll show this here in the actual product and the community edition. So the data scientists are the producers, app developers are the consumers. We show very easy ways to get the Python code and the C# code, the Java code to actually integrate with what these data scientists are offering. So on the like integration front, of course, MLflow, Kubeflow. I didn't put in here just out of forgetfulness. I didn't put SageMaker and Azure ML and Google ML. So these are essentially the cloud providers' offerings. So we know that there's no way that we're going to get people to not use Amazon or to stop using Azure ML. So the best, you know, if you can't beat them, join them kind of thing, right? And we're a very inclusive crowd and you know, group of people, and you all are too. So let's all play nice and get things working with each other and give people real options. And that's how we feel about this. All right. Okay, and I guess the next one would be demo here. So let's see how this goes. So this is our community. If you guys wouldn't mind, you can log in here. So log in. I'm going to log in. You can log in with GitHub. You can log in with your Microsoft Live account if you have one, or Gmail. I think I'm going to do GitHub here. Actually, I think let me go back to using my email. Community@Pipeline. Okay, so here we are. We're presented, and we have about 13 minutes left, so I just want to go through and show. These are all the samples that we have. Now we're actually, this weekend, we're finishing up a Spark, and the ability to take Spark ML models and put them online without having a Spark cluster, and this is huge. So we'll be offering this like later this week once we get it fully tested. Same with MXNet. We actually do have a sample that works, but we want to document it better. And then by the end of the month, we'll have TensorFlow JS, and that's in line with the meetup that's happening on October 30th. We actually do have a couple PMML samples, so we're going to work to expose. The short of it here is we have most of these examples, but they're not to the quality of the first 6, and we want to make sure that you guys have good samples to work off of. We do support H2O. They're like Mojo files. We've got folks using R as well too. So what happens here is I can actually go and click projects. And projects, I'm going to click sample, and I want to do a Scikit-Learn. And this is, so this, now I can also follow the quick start. And so just so you guys know, this is actually using MLflow inside. So if you remember the old Intel inside, we do use parts of Kubeflow, and we do use parts of like MLflow, specifically MLflow's experiment tracking. So these actually end up being experiments within the MLflow world, and we feel our UI is very, very much geared towards getting these things into production, whereas MLflow itself is just kind of show me all the experiments. So we're trying to find a nice, like, healthy balance in there. So once you actually get it in here, okay, for those of you raising your hands, can you put the questions in the chat? Because I can't seem to answer your raised hand. I haven't figured that part out. So once so this is a trained model. So this trained model has been uploaded. We can now choose where do we want to deploy it. And this, obviously for the professional edition and the enterprise, you will have had to set things up and either VPC peer or actually install it on your cloud itself. And we have ways to do both. Next, we're going to choose the hardware. If it's CPU, GPU, TPU. So this is if you're in Google. And then there's a bunch of these, model optimizations you can make. So this is after the model has been trained, right? Like, keep in mind that the model has been trained, and we have two places to make optimizations. We can either optimize the model itself using layers, and these depend on the type of model. So if it's a neural network or if it's a multi-layer perceptron, there's things we can do here. Select runtime optimizations. So this is the actual runtime itself. I could choose to have, to have batches of 20 milliseconds. This means every 20 milliseconds, take all of the prediction requests, pass them to the underlying model, and make one big prediction, and then take the results and then send it back to the caller. So this is really high throughput type of situations, and then also depending on the type of model. Now this is a Scikit model. Right now we can only do Python for the runtime. There is quite a bit of work going on being able to convert Python code. There's a project called AutoGraph that'll convert just regular Python code into TensorFlow. And then you get all the benefits of TensorFlow and the C++ back and TensorFlow serving. And so we've been starting to incorporate some of that stuff where there will be a second runtime here that's going to be TensorFlow, basically for Scikit. So yeah, keep an eye out for that. That's pretty exciting. Let me see here if this thing is done. There's probably a lot of people hitting the server now. All right, and then what's next? So once we have a project in here, oh yeah, so I do want to talk about this. If there's multiple projects, you can actually ensemble and combine them and dynamically create a new project, a new model, if you will, that combines multiple projects or multiple models into one. And one thing to highlight here, so let me go back actually to the screen. Let me see here if I click. Okay. Sorry, I'm clicking around a bunch here. Okay, and so when there's multiple, so it looks like this completed. Now this should flip over to ready. And let me hit the refresh here. Okay, so that one's ready. Let's give this one 100%. I'm going to click predict, and I'm going to click test, and okay, it might still be coming up there. So this is where you could actually run the prediction. You can take the consumer if it's, so this is where the application developer would come in and they would grab the code that they need, has the endpoints. Now, also you can set up, let's try it again. There we go. So here we got the prediction back there. If you do have a binary, you could try to upload it there if your model supports the binary. Otherwise, this particular model, this specific one is taking an JSON representation of an image. And that's just how this application was planning to use it. So that's how they wrote it. The other thing here is I can actually compare. So here, all the models they're all properly returning a 7. However, and so I can click on here and drill in and see the confidence and some other stuff. If I wanted to see, or if, and this bubble gets bigger as more and more models come in with that same prediction. At this point, I could actually look at any outliers and click into them and see what led them, and then back up and see which variant it was. And so this is where we found that CUDA bug. We found one model variant that was consistently predicting the wrong digit for this particular model. So taking it one step further, we have explanation. So here's where in real time, and you start seeing some of the charts come up here. In real time, so we can actually explain how did this particular model get to this prediction. And if it's only a single, if it's one single model and not an ensemble, we will only see one of these. But if it is an ensemble, right, like we could actually drill in and see which parts of the ensemble showed, or what led to each particular prediction. So red is something led negatively, blue, something led positively to this prediction. We can also, if it is multi-models, this is just one single model participating, but if it was multiple models, we would see multiple branches in this graph, and we could see how much time is being spent. This is the familiar like Jaeger UI, as a lot of you know. There's no reason to reinvent this wheel. It's a very, very stable tool that integrates very nicely with your applications. And here we can see how much time is being spent here, right? And this looks like actually a failed response, so we would want to drill in and see what the failure was. We've got Kibana and Elasticsearch. We have the whole EFK. We have FluentD that runs on all the nodes, all of this. We've got Prometheus that's integrated here as well too, and of course our favorite, Jupyter. So we love JupyterLab. We were one of the very, very early adopters of JupyterLab, and we get a lot of feedback to that community, get a lot done, very productive community. Here you can see some of the GitHub integration. So I'm gonna do, let's see, this is PipelineAI. You can see all of our repos and pipeline. We can drill into an individual repo. Now we have, all of these notebooks are in PipelineAI/notebooks. And all of these are all of the models that feed into the community edition are here. So MNIST-v1, this is the TensorFlow version, there's Keras version. Pretty much every language, every type, there's a sample there. If there's something that we don't cover, just let us know and it goes into the prioritization. Streams, we have not yet exposed. We are very, very streaming focused. We are spending quite a bit of time making sure it's like generic enough, it's easy to wire up predictions. So the exact same predict function that powers this like REST API can also predict off of a stream. And this is very important to us, that the exact same code can be used. Here's also, by the way, where we could put stuff into shadow mode. That'll drop its live traffic to 0, but then shadow it, so best effort, the inputs going in. And this really gives us a safe way, if there were multiple variants here, to test out our thoughts. Maybe we woke up with a thought on how to improve the model, and now we want to actually push it into production and see how it's doing safely. We could tear it down safely, no impact on the actual end user. We can manually scale up here. We could also employ our auto routing mechanism, auto shifter is what I call it. And right now, out of the box, we have 3 different goals: minimize cost, minimize latency, maximize throughput. If these 3 don't work for you, if you have some other way of defining when we should shift traffic from one variant or one cloud to another, you would click new. That would send you into where you can create your own function. So very much like the Lambdas of the Amazon world. So pretty cool stuff here. Okay. And I see some hands being raised. You could also set auto scaling, same kind of thing. If these don't do it for you out of the box, you would click new, create your own function that works off of any Prometheus metric. We have Prometheus set up here. We can integrate with Datadog, with CloudWatch. There's all the connectors for that. So yeah, I hope you guys enjoyed this. Let me look at the questions real quick. I know one person's raising their hand. I can't see the hand raises, so put the questions in here. Okay, let me back up. So Cloudflare, what is Docker? Okay, so once again, web service. For those of you that have more questions, just send me the question directly. You can either click this thing in the bottom right that pops up and you know, click new conversation, and you can talk to one of us and we'll help you out. Once you have a prediction, there's a tool for roughing it. Right, so the prediction, so these are REST endpoints. And in fact, I'll build another one here right before your very eyes. I've imported the model that was trained. I'm selecting CPU. I can apply, so every time I do a switch, one new Docker image will be created. And each of these ends up being a model variant. So if I did all 4 of these, I would actually end up with 4 like Docker images. If I did 2 of these, if I did CPU and GPU and these 4, I would have 8. If I did, you know, 3 different versions here, I would have all the different combinations, all the combinatorial. So like this is where the number of models that you can try goes up exponentially with the number of options that you have here. Finally, the runtime. So this is a Python model. I haven't picked let me just get this one deployed with just Python, but let me pick a new sample that has TensorFlow or Keras. I'll do. Everyone loves Keras. Thanks for answering about Docker. Yeah. Okay, so we're going to let that thing run. Is it like TensorFlow lib? Okay, so TensorFlow is one of the options here. How to use CUDA for GPU processing. Right, so what the great thing about the more modern ML frameworks like Keras and PyTorch, there's almost no code changes to the way that you use the GPU. All you have to do is give it an alternate runtime that, or like TensorFlow serving, for example, that is that has GPU support, or the like Onyx, which is like PMML, but 40 years later, have like an Onyx runtime that with just one different flag will do the GPU or the CPU. So there's, you know, in the old days, like what I call ML 2.0, which is like Scikit and you know, R and things like that. You know, it's not easy to go from CPU to GPU. There's actually major code changes. And please send us the PPT of the presentation. Okay, survey results. Anyone can use the platform to train a model and not just deploy? Or is this? So our focus, because we're a small startup, we have to pick an area that we like and that we are excited about and that we feel is under-engineered and underfunded. And so for us, there's so many players in the training space. We would rather work with those players. It's a lot of people that we know. It's my former company, Databricks. Also did some time with the IBM Spark Tech Center. So we're working with IBM. And our focus is post-training, right? That's a good way to put it. We don't call it the deploy or the predict. We actually consider all the optimizations as part of our product, not just the predictions, because at that point we're just Jenkins. And there's a lot of companies out there that when you peel away the layers, you'll see all they are is Jenkins, and there's some value to that. You know, it's like machine learning focused Jenkins, but for us, it's not something we would pay for and like outside vendor, and we don't want to build that. So what are we trying to upload? Serialized pickle file. So in some cases, yes, if you follow the quick start, you would essentially be training and exporting the pickle file. That's what the samples do within quick start. And then you're uploading the pickle file, correct. But you're also uploading the input transformer and an output transformer, which you'll see in the example here. I go to quick start. Actually, I'm going to go to, there's a models repo. Okay, so let's go to, let's see, Scikit, for example. So Scikit, the MNIST version here, if I look at the train method, so again, you can do training with pipeline. We just want to make sure that we're very clear that all that we support and our main focus is after the model's been trained. Taking on the support for the training side it's a much different skill set that we're all capable of because we spent the last like 10 years doing it. But our focus and our unique value add is on the post training. But yeah, here we're actually doing, we should be pickling this off somewhere, job-lib dump. And once that's dumped out, that ends up being this model PKL. And when you follow the Scikit quick start, which is off of quickstart.pipeline.ai, and it's basically just doing this, it's going to bundle up this entire project and send it to Pipeline. And Pipeline knows how to do things with pipeline underscore. So the more that you give it, the more features you're taking advantage of, but the bare minimum is just pipeline invoke. So this thing here. This is the bare minimum. There's even a much simpler version than this, but this is pretty simple. Here's these transformers. So here's transforming from JSON into a NumPy array. And then here is converting NumPy into JSON. If you were working with the Kafka version and you wanted to use Avro, here we're just using JSON for both Kafka and the web request. But you could actually add a new set of transformers here that work with Avro and not JSON. So pretty straightforward. And then we just have like a simple test method in here to test it. So that's the gist. That's how this stuff works. There's test request, test response, so we can actually set up automated tests to make sure that these are working. Okay, can we do side-by-side statistical analysis deployed to more than one environment to gauge which is more important? We snap the metrics and do a compare. Okay, so Raj asked a really good question. Can we, how formal statistical analysis, and some people have gone as far as to call this automated canary analysis to compare multiple models, even that are running in different. And so I think your question, because you can certainly do it in real time, right? And that's our focus now. We are storing all of these metrics in Prometheus. We're pushing them to wherever you want us to push them. We've worked on a lot of framework teams, and we've worked with a lot of people like us but on the other side. And we don't want people telling us what where to get our metrics from, or where to be running queries from in our Spark jobs. We want these people, so us, to integrate with the enterprise and reuse their existing ways. So the short answer here is you would be running queries just like you're doing today, using Spark, using Hadoop, and comparing that way. Or you would be looking at the last hour or the last 3 hours of activity directly within here. So one thing I haven't shown, just because it's a little too opsy, but I'll show it to you, is Grafana. And you could actually slice and dice and search on specific models and specific tags. And this is also the health of the clusters. So this is as far back as you want. So this is from the ops. But I think your question is, can we do more advanced statistical analysis that does require more compute power from a Spark cluster? And that's certainly possible, of course. And there's Spark Prometheus adapters. There's Spark Datadog, Spark CloudWatch adapters. Can we call PipelineAI's toolkit to prediction? Okay, I don't quite understand toolkit to prediction. So Eduardo, if you mean, is there a CLI? There certainly is a CLI, and you'll see you can upload the model either to our hosted community or to your installed community. And you can upload models, you can change the routes, you can change the route percentage, you can change the auto scale capabilities. You can pretty much do everything from the command line. The command line uses the REST API and the REST API. Actually, that's another thing to point out. We actually do have a REST API as well. And this is all Swagger documented, Open API documented, and you can integrate with your own applications. Because we're very much a platform, we know that we're going to be integrating into other people's applications, and we want to make that as easy as possible. So everything here is, you can click on it, look at the details, we have examples. You can try out things here yourself, actually put in the inputs, click you know, test, and then it'll return, yeah, try it out kind of thing. How to upload 600 terabyte data set. Okay, so, you know, again, the 600 terabyte data set to me sounds like a training question. So just to remind you that while we can use Pipeline for training, we are very much optimized and we're honed towards model serving. That said, if you had a 600 terabyte model file, we certainly, you know, wouldn't want you to have to do that through HTTP or, you know, drop zone. So the short of it is we have S3 integration. We have all the cloud provider integrations. This is easy. And we also have Dropbox like integration too, and I think Box as well. I always get those two confused. But so the short of it is if you want to do batch predictions off of 600 terabytes, that you would use the S3 integration or your cloud provider. So in that case, you wouldn't really be uploading. You would just, in fact, there's a notebook that shows this example. We have a notebook calling into S3. Oh, no, I spelled it wrong. Oop. Hang on here. There's a notebook showing how to get to S3 here. Okay. So this is TensorFlow talking to S3 directly. And Keras just got support for this exact feature, talking from Keras to S3 and through the TF dataset like API. So this is TensorFlow's dataset API. So we're actually on the very latest of TensorFlow. We're on 112.0 RC0 that was released a couple days ago. And this 112 is really the new, if you skip 111, that's fine. Just go to 112. There's actually quite a lot of new CUDA. They've moved beyond CUDA 9, which had the bug, up to 10. XLA is now turned on. They're really preparing for the TensorFlow 2.0 release, which will probably be either at maybe KubeCon. I don't think so. I think it'll be early next year. Could you have me a few links to learn machine learning, deep learning from the projects here? So people wanting to learn machine learning, yeah, there's a lot of resources out there. You know, Coursera is all the normal stuff. We're a bit of an advanced machine learning use case for people that have this problem of getting machine learning into production, but we also off of YouTube. If you go to community.pipeline.ai, or sorry, if you go to pipeline.ai and community tab, there's a lot of videos, a lot of resources. Be prepared to spend like every weekend from now and for the next 3 or 4 years to get to a place where you're really comfortable with these things. If you're not doing it full time, it's going to take a while. Manage Canary deployments. Yes, so Canary deployments, the most basic way to do it through the UI is by default, we're putting things into shadow mode, and then you would either manually increase it here or do it through the CLI, do it through your Jenkins, do it through, and let's see, automate it. So this is one way to do it through the UI. The second way to do it is the CLI. The third way that we're working on is the automated canary analysis, and that's where you will give us a function or to like analyze the results of these models in production. And you know, so this could either be Prometheus metrics, this could be right, like, yeah, any kind of custom signal that you're listening on. So like one of the cool things about us as a platform is we are extensible. You can insert functions wherever you need to, fill in custom things. As a platform, we also keep an eye on what people are creating. And if we see over and over people are using a particular metric for something, for auto scaling, for example, we will then add it as a feature here. So, these are the basic ones that we think of, the request queue size. If you want to manually scale, you could do it, up to 10 with Community Edition. This will actually create, 10 Docker images, for example, or Docker containers that are spread across the cluster. And let's see, what else? Let me bring that back down to 1 otherwise. GPU are only the cancel. Yeah, so GPU, so you can get to GPUs from the notebooks. And let's see, this is community call. Can't seem to spell community today. If I go to explore environments, if I go, well, actually, if I click on GPU, there's explore GPU. So you'll see it here, boom. So you can use GPUs in the notebooks, but when you go to deploy, you can right now only select CPU. And that's just a matter of cost right now. If you do want to explore the GPU stuff, we can certainly get you onto a box that we dedicate to you, and you can play with the paid edition. Yeah, free trials and all that stuff. Do we need DevOps for big data or data science? Yeah, no. So, and then just one quick question, or one quick answer on the rollback question. Yes, so essentially you would either manually through the UI or through the command line or through the REST API, you can dial this back down to 0. And if you want to get rid of it completely, just change that to 0 or click on delete here. And you'll want to, of course, keep this something scaled up to 100. So I just did that to 100, and now that one's taking all the traffic. Do we need DevOps for big data or data science? So in some ways, we are the like DevOps like replacement. We don't even like to talk about DevOps. We're just talking about capabilities. So the fact that you have to talk about DevOps means that that layer is exposed, and now you're talking about automation and all kinds of the, that's 10 years ago type thinking. Like today we speak in capabilities, and our product, we're talking about things you can do. So getting the data scientist or the application engineer to get models into staging or like directly to production quickly and safely, that's our mission. So yeah, call that whatever it is, but we're hiding all of those details of Kubernetes and that kind of thing. Okay, so now we're asking about job stuff. So yeah, don't have too much to offer on that side. Pipeline's hiring, by the way. We're looking for the typical solution engineers and GPU specialists and all over the board. So contact us. And I hope you guys enjoy this. We're already 16 minutes over, so I'm going to cut it here. Shoot me an email, chris@pipeline.ai. And thanks for spending your Monday with me. Oh, also, workshop. I do want to mention, get the link here. We have a 4-hour version of this coming up on October 20th. I'm getting you guys a discount code right here. Since I have you. Let's see, advanced. Let me give you guys this. Okay, so here's a code for upcoming workshop on October 20th, Saturday, 4 hours online. Boom. And hope to see you guys soon. So that'll be much more hands-on than this. We covered a lot in 1 hour, but we'll actually do much more hands-on stuff when we see you guys soon. Workshop, workshops are always recorded. We do this for the community, of course. Of course. Thanks, guys. See ya.